Picture this, a fiery sphere, alive with energy, suspended in the endless void of space. This is our sun, not just a distant star, but a dynamic, ever-changing force of nature. Its surface churns with activity, and from this chaos, something extraordinary emerges: loops of glowing plasma, stretching thousands of miles into the void. These are solar prominences, nature's own cosmic ballet, twisting and dancing in the sun's magnetic embrace. Imagine ribbons of fire, glowing with the intensity of a million sunrises, arcing gracefully against the backdrop of the universe. What secrets do these loops hold? What mysteries do they whisper to those who dare to look closer? Tonight, as you drift into the realm of dreams, let's journey together into the heart of our solar system, where the sun's fiery breath paints the cosmos with beauty and wonder. Where are you joining us from, and what time is it there? As the stars twinkle above, let's unravel the enigma of these solar prominences and discover the stories they tell about the universe we call home. Now, let's take a closer look at what solar prominences truly are. Imagine the sun as a vast, fiery ocean, its surface constantly churning with energy. From this turbulent sea, enormous loops of glowing plasma rise, stretching far into the sun's outer atmosphere. These are solar prominences, massive, arching structures that can reach heights of tens of thousands of miles, dwarfing even the largest mountains on Earth. Picture them as colossal bridges of fire, suspended in space, glowing with the brilliance of a million sunrises. Solar prominences are made of plasma, a superheated state of matter where atoms are stripped of their electrons, creating a swirling, electrically charged gas. This plasma is shaped and held together by the sun's powerful magnetic fields, which twist and pull it into these stunning loops. Unlike sunspots, which are cooler, darker patches on the sun's surface, or solar flares, which are sudden bursts of energy, solar prominences are more stable and can last for days or even weeks. They are like the sun's slow, graceful dancers, moving with a rhythm dictated by the invisible forces of magnetism. To grasp their scale, think of Earth. If our planet were placed next to a solar prominence, it would look like a tiny marble beside a towering skyscraper. These loops of plasma are not just beautiful, they are also a window into the sun's inner workings, revealing the intricate interplay of heat, gravity, and magnetism that shapes our star. As we continue our journey, we'll explore how these mesmerizing structures form and what they tell us about the sun's fiery heart. Now, let's shift our focus to the fascinating science behind plasma, the very essence of solar prominences. Plasma is often called the fourth state of matter, but what exactly does that mean? Unlike solids, liquids, and gases, plasma exists in a unique state where atoms are so energized that their electrons break free, creating a swirling sea of charged particles. This superheated, electrically charged gas is what makes up the sun and fuels its incredible phenomena, including those mesmerizing loops of plasma we call solar prominences. On the sun, plasma forms under extreme conditions. The intense heat, reaching millions of degrees, strips atoms of their electrons, leaving behind a chaotic mix of positively charged ions and free electrons. This plasma is not just hot, it's also highly responsive to magnetic fields, which is why it plays such a crucial role in shaping solar prominences. Unlike solids, which have a fixed shape, or liquids and gases, which flow freely, plasma behaves in a way that's almost otherworldly. It twists, bends, and spirals, following the invisible lines of magnetic force that crisscross the sun's surface. One of the most remarkable properties of plasma is its ability to conduct electricity and generate magnetic fields. This creates a dynamic feedback loop. The sun's magnetic fields shape the plasma, and the moving plasma, in turn, influences the magnetic fields. It's this intricate dance that gives rise to solar prominences, as well as other solar activities like solar flares and coronal mass ejections. Without plasma, the sun would be a very different place, a quiet, lifeless ball of gas instead of the vibrant, dynamic star we know. Understanding plasma helps us appreciate not just the beauty of solar prominences, but also the incredible forces at work on the sun. It's a reminder that even the most familiar things, like the light and warmth we receive every day, are powered by processes that are anything but ordinary. As we continue, we'll explore how these magnetic forces and plasma come together to create the stunning loops that captivate astronomers and stargazers alike. Now that we've explored the science of plasma, let's dive into the captivating process of how solar prominences form. Picture the sun's surface, a seething cauldron of heat and energy, where temperatures soar to millions of degrees. It's here, in this chaotic environment, that solar prominences begin to take shape. But how exactly do these massive loops of plasma come to life? The answer lies in the delicate balance between two powerful forces, gravity and magnetism. The sun's intense heat plays a crucial role in this process. As the plasma on the sun's surface heats up, it becomes highly energized, causing atoms to lose their electrons and creating a sea of charged particles. This superheated plasma is then influenced by the sun's magnetic fields, which act like invisible threads weaving through its atmosphere. These magnetic fields are generated by the movement of plasma itself, creating a dynamic and ever-changing environment. As the magnetic fields twist and turn, they can trap pockets of plasma, lifting it away from the sun's surface. Gravity, however, constantly pulls the plasma back down, creating a tug of war between these two forces. When the magnetic fields are strong enough, they overcome gravity, allowing the plasma to rise and form the towering loops we see as solar prominences. These loops can stretch tens of thousands of kilometers into space, defying the sun's immense gravitational pull. The interplay between gravity and magnetism doesn't stop there. As the plasma rises, it follows the curves of the magnetic field lines, creating the elegant, arching shapes that make solar prominences so mesmerizing. Sometimes, these loops remain stable for days or even weeks, gently swaying in the sun's atmosphere. Other times, the magnetic fields become unstable, causing the plasma to erupt violently into space in what's known as an eruptive prominence. This delicate dance of forces is what gives solar prominences their unique character. Without the sun's magnetic fields, the plasma would simply fall back to the surface, and without gravity, the loops would drift aimlessly into space. It's this perfect balance that allows us to witness one of the most stunning phenomena in our solar system. As we continue, we'll take a closer look at the different types of solar prominences and how they behave, revealing even more about the sun's dynamic and ever-changing nature. Now that we've seen how solar prominences form, let's explore the different types that grace the sun's surface. Solar prominences come in various forms, each with its own unique behavior and appearance. The two most common types are quiescent prominences and eruptive prominences, and understanding their differences gives us a deeper appreciation for the sun's dynamic nature. Quiescent prominences are the calm and steady giants of the solar atmosphere. These structures can last for weeks or even months, gently arching above the sun's surface like serene bridges of plasma. They often appear as long, thin loops that stretch tens of thousands of kilometers into space. When viewed from Earth or through space telescopes, quiescent prominences stand out as dark, ribbon-like features against the bright backdrop of the sun. Their stability comes from the balance between the sun's magnetic fields and gravity, allowing them to maintain their shape for extended periods. On the other hand, eruptive prominences are the dramatic counterparts to their quiescent siblings. These are the ones that capture our attention with their explosive energy. Eruptive prominences occur when the magnetic fields holding the plasma become unstable, causing the loops to break free and burst into space. These eruptions can send massive amounts of plasma hurtling outward at incredible speeds, sometimes reaching millions of kilometers into the solar system. When observed, they appear as bright, fiery arcs that suddenly expand and dissipate, leaving behind a trail of glowing material. The lifespans of these prominences vary greatly. While quiescent prominences can linger for weeks, eruptive prominences are fleeting, often lasting only a few hours or days before they vanish. This contrast highlights the ever-changing nature of the sun's atmosphere, where stability and chaos coexist in a delicate balance. Observing these phenomena from Earth or space offers a breathtaking view of the sun's activity. Quiescent prominences are often seen during solar eclipses, appearing as delicate, glowing arcs along the sun's edge. Eruptive prominences, however, are best captured by space-based observatories like the Solar Dynamics Observatory, which can track their rapid movements and dramatic transformations in real time. As we continue, we'll delve into the role of magnetic fields in shaping these prominences, uncovering how the sun's invisible forces create such stunning displays of plasma. Now, let's turn our attention to the invisible forces that shape these mesmerizing loops of plasma, the sun's magnetic fields. These fields are the true architects behind the beauty and chaos of solar prominences, guiding the plasma into the intricate loops and arcs we observe. Without them, the sun's surface would lack the dynamic structures that captivate astronomers and stargazers alike. At the heart of this process is a phenomenon called magnetic reconnection. This occurs when the sun's magnetic field lines, which are constantly shifting and twisting, break apart and reconnect in new configurations. Imagine two rubber bands snapping together after being stretched to their limits. This sudden release of energy is what drives the formation of solar prominences. Magnetic reconnection not only creates the loops of plasma, but also fuels their movement, causing them to rise and twist in dramatic fashion. Another key player in this cosmic dance is the flux rope. Picture a coiled spring made of magnetic field lines, tightly wound and filled with hot plasma. These flux ropes act like the skeleton of a solar prominence, providing the structure that holds the plasma in place. When the magnetic fields within these ropes become unstable, they can trigger the explosive eruptions we see in eruptive prominences. The interplay between the magnetic fields and the plasma creates a delicate balance, where even a small shift can lead to spectacular displays of solar activity. The sun's magnetic fields are incredibly complex, constantly shifting and interacting in ways that scientists are still working to fully understand. These fields are generated deep within the sun, in a layer called the convection zone, where the churning motion of hot plasma generates electric currents. These currents, in turn, produce magnetic fields that rise to the surface, creating the patterns we observe. What makes these magnetic fields so fascinating is their ability to shape the sun's atmosphere on such a grand scale. They not only form the loops of plasma we see as prominences, but also influence other solar phenomena like sunspots and solar flares. The magnetic fields act like invisible hands, sculpting the sun's outer layers into a dynamic and ever-changing landscape. As we continue our journey, we'll explore how these magnetic fields are observed and studied, shedding light on the tools and technologies that allow us to peer into the sun's hidden forces. The story of solar prominences is, at its core, a story of magnetism, a force that shapes not only the sun, but the entire solar system. Now, let's shift our gaze from the sun's magnetic mysteries to how we, here on Earth, can witness these stunning solar prominences firsthand. Observing these loops of plasma isn't as simple as looking up at the sun on a clear day. It requires specialized tools and techniques to safely capture their beauty and study their behavior. One of the most common tools used by astronomers is the hydrogen alpha telescope. This specialized instrument is designed to filter out all but a specific wavelength of light emitted by hydrogen, the primary element in solar prominences. By isolating this wavelength, the telescope reveals the intricate details of these plasma loops, allowing us to see their structure and movement in stunning clarity. For amateur astronomers, hydrogen alpha telescopes are a fantastic way to start exploring the sun's surface and atmosphere, offering a window into its dynamic activity. Another essential tool is the solar filter, which can be attached to standard telescopes to safely observe the sun. These filters block out most of the sun's intense light, reducing it to a level that's safe for viewing. Without them, looking directly at the sun through a telescope could cause serious damage to your eyes. Solar filters come in various types, including glass and film-based options, and they allow you to see not only prominences, but also other solar features like sunspots and granulation. For those just starting out, a simple pair of solar eclipse glasses can also provide a safe way to observe the sun. While they won't reveal the fine details of solar prominences, they're a great way to get acquainted with the sun's surface and prepare for more advanced observations. Why are these observations so important? Studying solar prominences helps scientists understand the sun's magnetic activity and its impact on space, weather. By tracking the formation, movement, and eventual dissipation of these plasma loops, researchers can predict solar storms and other events that could affect Earth's technology and infrastructure. For amateur astronomers, observing solar prominences is not only a thrilling experience, but also a way to contribute to citizen science projects, where their observations can support professional research. As we continue to explore the sun, the next chapter of our journey will take us back in time, uncovering how solar prominences were first discovered and the milestones that have shaped our understanding of these cosmic wonders. The story of solar prominences is one of both science and curiosity, reminding us that even the most distant phenomena can be brought closer through observation and discovery. Turning our attention to the past, let's step back in time to uncover the fascinating history of solar prominences and how humanity first began to unravel their mysteries. The story of solar prominences is as much about human curiosity as it is about the science behind these glowing loops of plasma. The first recorded observations of solar prominences date back to the early 19th century. During a total solar eclipse in 1842, astronomers noticed bright, flame-like structures extending from the darkened edge of the sun. These structures, which we now know as solar prominences, were initially thought to be mountains or clouds on the sun's surface. It wasn't until later that scientists realized they were witnessing something far more extraordinary: loops of plasma suspended in the sun's atmosphere. One of the key figures in the study of solar prominences was the French astronomer Pierre Janssen. In 1868, Janssen made a groundbreaking discovery during another solar eclipse. He observed a bright yellow line in the spectrum of light emitted by the prominences, which he later identified as the signature of helium, a gas that had never been detected on Earth before. This discovery not only advanced our understanding of solar prominences, but also marked the first time an element was discovered in space before being found on our own planet. Around the same time, English astronomer Norman Lockyer was also making significant contributions. Lockyer developed the spectroscope, a tool that allowed scientists to analyze the light from the sun and other stars in unprecedented detail. Using this instrument, he confirmed Janssen's findings and further explored the composition and behavior of solar prominences. Together, Janssen and Lockyer laid the foundation for modern solar astronomy, showing that the sun's atmosphere was far more complex and dynamic than anyone had imagined. As the 20th century dawned, advancements in technology brought new ways to study the sun. The invention of the coronagraph in the 1930s by French astronomer Bernard Liot allowed scientists to observe solar prominences without waiting for an eclipse. This device artificially blocks the sun's bright disk, mimicking the conditions of an eclipse and revealing the fainter structures in its atmosphere. With this tool, researchers could study prominences more frequently and in greater detail, leading to a deeper understanding of their formation and behavior. Today, our knowledge of solar prominences continues to grow, thanks to the work of countless scientists and the development of advanced instruments like the Solar Dynamics Observatory. But it's important to remember that this journey began with simple observations during eclipses and the curiosity of early astronomers who dared to ask questions about the sun's fiery features. As we move forward, let's explore how these historical discoveries connect to the broader picture of solar activity and its impact on our planet. The story of solar prominences is a testament to the power of observation, innovation, and the relentless pursuit of knowledge. Now, let's shift our focus to the powerful connection between solar prominences and the dramatic events known as solar storms. These loops of plasma, while mesmerizing, are not just beautiful features of the sun. They play a crucial role in some of the most energetic phenomena in our solar system. Solar prominences are often linked to solar storms and coronal mass ejections, or CME, which are massive bursts of solar material and magnetic fields hurled into space. When a solar prominence becomes unstable, it can erupt, sending vast amounts of plasma and magnetic energy outward. This eruption can trigger a coronal mass ejection, a colossal explosion that propels billions of tons of charged particles into space at incredible speeds. These particles travel across the solar system, and if they are directed toward Earth, they can interact with our planet's magnetic field, creating what we call a solar storm. The effects of these solar storms can be both awe-inspiring and disruptive. On one hand, they are responsible for the stunning auroras that light up the polar skies, painting the night with vibrant colors. On the other hand, they can pose significant challenges to our technology. When the charged particles from a solar storm reach Earth, they can interfere with satellites, disrupt communication systems, and even cause power grid failures. In extreme cases, a powerful solar storm could potentially knock out entire electrical networks, leaving cities without power for hours or even days. Base weather, the term used to describe the conditions in space influenced by the sun, is directly affected by these solar storms. Scientists monitor solar prominences and CMEs closely to predict when a solar storm might occur and how intense it could be. This monitoring is crucial for protecting our technology and infrastructure, as well as ensuring the safety of astronauts in space, who are more vulnerable to the harmful effects of increased radiation during these events. Understanding the connection between solar prominences and solar storms is not just about appreciating the sun's power, it's about preparing for its impact on our daily lives. As we continue to explore the mysteries of the sun, we gain valuable insights into how to safeguard our planet and our technology from the unpredictable nature of space weather. Next, we'll take a closer look at the beauty of these solar phenomena and how they inspire both scientists and dreamers alike. Now, let's take a moment to marvel at the sheer beauty of solar prominences. These magnificent loops of plasma, stretching thousands of kilometers into the sun's atmosphere, are not just scientific wonders. They are breathtaking works of art, painted by nature itself. Imagine fiery ribbons of glowing plasma, arching gracefully against the dark backdrop of space, their delicate curves and vibrant hues capturing the imagination of anyone who gazes upon them. Base observatories like the Solar Dynamics Observatory, or SDO, have gifted us with stunning images and videos of these phenomena. Through their lenses, we can witness the intricate details of solar prominences, how they twist, sway, and sometimes erupt in a dazzling display of cosmic energy. The plasma, glowing in shades of red and orange, contrasts beautifully with the sun's golden surface, creating a visual spectacle that feels almost otherworldly. What makes these loops of plasma so captivating is not just their appearance, but the sense of mystery they evoke. Each prominence tells a story of the sun's dynamic nature, a reminder of the immense forces at play in our star. For scientists, they are a source of endless fascination, offering clues about the sun's magnetic fields and the processes that drive solar activity. For dreamers and stargazers, they are a source of inspiration, a glimpse into the raw beauty and power of the universe. The beauty of solar prominences also lies in their fleeting nature. Some last for days, while others vanish in a matter of hours, making each observation a unique and precious moment. It's this combination of grandeur and transience that makes them so mesmerizing, a reminder of the ever-changing, ever-evolving cosmos we are part of. As we continue to explore the sun and its many wonders, solar prominences stand as a testament to the artistry of the universe. They remind us that even in the vastness of space, there is beauty to be found, waiting to inspire and ignite our curiosity. Next, we'll journey deeper into the sun's atmosphere, exploring the layers where these prominences form and the secrets they hold. Now, let's turn our gaze to the sun's atmosphere, a complex and dynamic region where solar prominences come to life. The sun's atmosphere is made up of 3 distinct layers, each with its own unique characteristics and role in shaping the solar phenomena we observe. The first layer, closest to the sun's surface, is called the photosphere. This is the layer we see when we look at the sun, often described as its surface. The photosphere is where sunlight is emitted, and it's marked by a grainy texture caused by the bubbling motion of hot plasma. While solar prominences don't form here, the photosphere plays a crucial role in generating the energy and magnetic fields that drive their creation. Above the photosphere lies the chromosphere, a thin layer that glows with a reddish hue during solar eclipses. This is where things start to get interesting. The chromosphere is a region of transition where temperatures rise sharply and magnetic fields become more active. It's here that solar prominences begin to take shape, as loops of plasma are guided by the sun's magnetic forces. These loops stretch upward, reaching into the outermost layer of the sun's atmosphere, the corona. The corona is the sun's outer atmosphere, a vast and mysterious region that extends millions of kilometers into space. Despite being farther from the sun's core, the corona is incredibly hot, with temperatures reaching millions of degrees. This is where solar prominences fully emerge, their glowing arcs of plasma suspended in the corona's tenuous gases. The corona's magnetic fields are the architects of these structures, shaping and holding them in place, sometimes for days or even weeks. Solar prominences interact with all 3 layers of the sun's atmosphere in fascinating ways. They often originate in the chromosphere, where magnetic fields become twisted and unstable. As they rise into the corona, they can grow to immense sizes, stretching hundreds of thousands of kilometers into space. Occasionally, These prominences become unstable and erupt, releasing massive amounts of plasma and energy into the solar system. Understanding these layers and their interactions helps us appreciate the delicate balance of forces that create solar prominences. From the photosphere's energy to the chromosphere's magnetic activity and the corona's vast expanse, each layer plays a vital role in bringing these cosmic wonders to life. As we continue our journey, we'll explore the life cycle of a solar prominence, from its formation to its eventual dissipation or eruption, and uncover the secrets of its ever-changing nature. Now, let's take a closer look at the fascinating journey of a solar prominence, from its birth to its dramatic end. The life cycle of a solar prominence is a story of balance, tension, and sometimes explosive release. It all begins deep within the sun's magnetic fields. As these fields twist and tangle, they create loops of plasma that rise from the chromosphere into the corona. This is the formation stage, where the prominence takes shape, guided by the sun's magnetic forces. These loops can grow to incredible lengths, sometimes stretching hundreds of thousands of kilometers into space. Once formed, a solar prominence enters a phase of stability. During this time, it hangs suspended in the corona, held in place by the delicate interplay between gravity and magnetic forces. Some prominences remain stable for days, weeks, or even months, glowing like ethereal arches against the sun's fiery backdrop. However, this stability is not permanent. The sun's magnetic fields are constantly shifting, and as they change, they can destabilize a prominence. When this happens, the prominence may begin to twist or stretch, its structure becoming more chaotic. This is the prelude to what scientists call an eruptive prominence. In some cases, the prominence will simply fade away, its plasma gradually dissipating back into the sun's atmosphere. This is a quiet end, a slow return to the solar environment from which it came, but in other cases, the prominence erupts, releasing a massive burst of plasma and energy into space. These eruptions can trigger solar storms and coronal mass ejections, sending shock waves through the solar system. The factors that influence a prominence's stability are complex. The strength and configuration of the sun's magnetic fields play a crucial role, as do the temperature and density of the surrounding plasma. Even small changes in these conditions can tip the balance, leading to either a gentle dissipation or a spectacular eruption. Understanding the life cycle of a solar prominence not only reveals the dynamic nature of the sun, but also highlights the intricate forces at work in our star's atmosphere. From its formation to its eventual end, each prominence tells a story of cosmic beauty and power. As we move forward, we'll explore how these solar phenomena connect to larger events, such as solar storms and their impact on Earth, uncovering the broader significance of these loops of plasma in the grand tapestry of the universe. Now, let's turn our attention to the broader impact of solar prominences and their role in shaping space weather. These magnificent loops of plasma are not just a spectacle to behold, they play a significant part in the dynamic environment of our solar system. When a solar prominence becomes unstable and erupts, it can release vast amounts of plasma and energy into space, creating what scientists call a coronal mass ejection. These eruptions are like cosmic storms, sending shock waves that ripple through the solar system and interact with Earth's magnetic field. The effects of these solar storms can be profound. For satellites orbiting Earth, the influx of charged particles can disrupt communication signals, damage sensitive electronics, and even shorten the lifespan of these vital technologies. Astronauts aboard the International Space Station are also at risk, as increased radiation levels during a solar storm can pose serious health hazards. On Earth, the impact is felt in the form of geomagnetic storms, which can interfere with power grids, causing blackouts and disrupting navigation systems. Monitoring solar prominences and their eruptions is crucial for predicting and mitigating these effects. Space agencies and observatories around the world keep a close watch on the sun, using advanced tools like the Solar Dynamics Observatory to track changes in magnetic fields and plasma activity. By understanding the behavior of solar prominences, scientists can provide early warnings of potential space weather events, giving us time to protect our technology and infrastructure. The connection between solar prominences and space weather also highlights the delicate balance between the sun and Earth. While these phenomena remind us of the sun's immense power, they also underscore the importance of studying our star to safeguard our modern way of life. As we continue to explore the mysteries of the sun, we gain not only a deeper appreciation for its beauty, but also the tools to navigate the challenges it presents. Next, we'll delve into how solar prominences have inspired myths, art, and culture throughout history, revealing humanity's enduring fascination with the sun and its fiery displays. Now, let's journey through time and across cultures to uncover how solar prominences and the sun itself have captured the human imagination. For centuries, the sun has been more than just a celestial body. It has been a source of wonder, inspiration, and even reverence. Ancient civilizations, awestruck by the sun's fiery displays, wove its mysteries into their myths, art, and daily lives. In ancient Egypt, the sun god Ra was believed to sail across the sky each day in a golden boat, bringing light and life to the world. The Egyptians saw the sun's rays as divine energy, and its daily journey symbolized the cycle of life, death, and rebirth. Similarly, in Aztec mythology, the sun was central to their cosmology. The Aztecs believed that the sun required constant nourishment, even through human sacrifice, to continue its journey across the heavens. The Greeks and Romans also held the sun in high regard. Helios, the Greek god of the sun, was said to drive a chariot across the sky, while his Roman counterpart, Sol, was celebrated in festivals and temples. These cultures saw the sun as a powerful force, capable of both creation and destruction, much like the solar prominences we observe today. In more recent history, the sun has continued to inspire artists and thinkers. The Romantic poets of the 18th and 19th centuries often used the sun as a symbol of beauty, power, and transcendence. Painters like J.M.W. Turner captured the sun's radiance in their works, using light and color to evoke its majesty. Even in modern times, the sun remains a powerful symbol in literature, film, and art, representing hope, energy, and the eternal cycle of life. Across cultures, the sun's prominences and fiery displays have been interpreted in countless ways. Some saw them as the breath of gods, while others view them as omens or messages from the heavens. These interpretations reflect humanity's deep connection to the sun and its role as a source of light, warmth, and life. As we explore these cultural connections, we gain not only a deeper appreciation for the sun's beauty, but also a sense of how it has shaped human history and creativity. Next, we'll take a closer look at the modern tools and technologies that allow us to study solar prominences in unprecedented detail, bringing us closer to unraveling the mysteries of our star. Turning our gaze to the present, we now have the remarkable ability to study solar prominences with tools that would have seemed like science fiction to those ancient civilizations. Modern technology has given us a front row seat to the sun's dynamic behavior, allowing us to observe these loops of plasma in stunning detail. One of the most groundbreaking tools in this field is the Solar Dynamics Observatory, often referred to as SDO. Launched in 2010, this satellite orbits Earth and captures high-resolution images of the sun every few seconds. Its instruments can observe different wavelengths of light, revealing the intricate structures of solar prominences and the magnetic fields that shape them. Another revolutionary mission is the Parker Solar Probe, which takes a much closer approach. Unlike other spacecraft that observe the sun from a distance, this probe ventures into the sun's outer atmosphere, known as the corona. It's designed to withstand extreme heat and radiation, allowing it to gather data from regions never before explored. By flying so close to the sun, the Parker Solar Probe provides invaluable information about the conditions that give rise to solar prominences and other solar phenomena. These tools, along with ground-based observatories equipped with specialized filters, have transformed our understanding of the sun. They allow scientists to track the formation, movement, and eventual dissipation of solar prominences in real time. This level of detail helps researchers predict solar activity, such as solar storms, which can impact Earth's technology and space weather. What makes these advancements even more exciting is how they bridge the gap between ancient wonder and modern science. While our ancestors marveled at the sun's fiery displays, we now have the tools to decode their mysteries. This blend of curiosity and innovation continues to drive our exploration of the sun, bringing us closer to understanding the forces that shape not only our star, but also the universe beyond. As we look ahead, the next section will delve into the fascinating world of eruptive prominences, where these loops of plasma can suddenly burst into space, creating some of the most dramatic events on the sun. Now, let's turn our attention to one of the most dramatic events on the sun, eruptive prominences. These are the moments when the sun's loops of plasma, which often appear calm and steady, suddenly explode into space. Imagine a massive arch of glowing plasma, stretching tens of thousands of miles above the sun's surface, only to violently break free and shoot outward. This is the essence of an eruptive prominence, and it's a sight that captures both the beauty and the raw power of our star. So, what causes these eruptions? The answer lies in the sun's magnetic fields. These invisible forces twist and tangle, storing enormous amounts of energy. Over time, the magnetic fields can become unstable, like a coiled spring ready to snap. When this happens, the magnetic loops holding the plasma in place can no longer contain it. The result is a sudden release of energy, propelling the plasma outward in a spectacular eruption. These events are not just visually stunning, they also play a crucial role in solar physics. Eruptive prominences are often linked to solar storms and coronal mass ejections, which are massive bursts of solar material and magnetic fields hurled into space. When directed toward Earth, these storms can interact with our planet's magnetic field, creating auroras and, in some cases, disrupting satellites, power grids, and communication systems. Understanding eruptive prominences helps scientists predict and prepare for these solar storms. By studying the conditions that lead to these eruptions, researchers can better forecast when and where they might occur. This knowledge is vital for protecting our technology and infrastructure, as well as for ensuring the safety of astronauts in space. But beyond their practical importance, eruptive prominences remind us of the sun's dynamic and ever-changing nature. They are a vivid reminder that our star is not a static ball of fire, but a living, breathing entity, constantly reshaping itself in ways we are only beginning to understand. As we continue to explore the sun, the next section will take us deeper into the solar cycle, revealing how the frequency and intensity of these prominences change over time and what this means for solar activity. Now, let's explore how solar prominences are deeply connected to the sun's natural rhythm, known as the solar cycle. This cycle, which lasts approximately 11 years, is like the heartbeat of our star, dictating the ebb and flow of solar activity. During this time, the sun transitions from periods of relative calm, called solar minimum, to phases of intense activity, known as solar maximum. And just as the seasons change on Earth, the behavior of solar prominences shifts dramatically throughout this cycle. At the start of the solar cycle, during solar minimum, the sun's surface appears quieter, with fewer sunspots and fewer prominences. These are the moments when the sun seems almost serene, its magnetic fields less tangled and more stable. But as the cycle progresses toward solar maximum, the sun becomes a hive of activity. The magnetic fields grow more complex, twisting and interacting in ways that create more sunspots, and in turn, more prominences. During solar maximum, the frequency and intensity of solar prominences increase significantly. It's as if the sun is waking up, unleashing its energy in spectacular displays. Eruptive prominences become more common, and the loops of plasma grow larger and more dynamic. This heightened activity is driven by the sun's magnetic fields, which become increasingly chaotic as the cycle peaks. But what does this mean for solar activity as a whole? The solar cycle doesn't just influence prominences, it shapes the sun's entire behavior. Solar flares, coronal mass ejections, and even the sun's overall brightness are all tied to this 11-year rhythm. By understanding how prominences change throughout the cycle, scientists can better predict when solar storms might occur and how intense they could be. Interestingly, no two solar cycles are exactly alike. Some are more active, with frequent and powerful prominences, while others are milder. This variability adds another layer of mystery to the sun's behavior, reminding us that even after centuries of observation, there's still much to learn about our closest star. As we look ahead, the next section will take us even further into the sun's influence, exploring how solar prominences play a role in the evolution of stars beyond our own solar system. Now, let's shift our gaze beyond our solar system and consider how solar prominences play a role in the life cycles of stars across the universe. While we often think of these loops of plasma as a feature unique to our sun, they are, in fact, a common phenomenon among stars, especially those similar to ours. Solar prominences, or stellar prominences as they are called when observed on other stars, offer a window into the dynamic processes that shape stellar evolution. Stars, much like our sun, go through phases of activity driven by their magnetic fields. For younger stars, these magnetic fields are often stronger and more chaotic, leading to frequent and dramatic prominences. These young stars are like energetic teenagers, full of vigor and prone to outbursts. As stars age, their magnetic fields tend to stabilize, and their prominences become less frequent, but no less fascinating. Interestingly, the study of stellar prominences has revealed that they play a crucial role in how stars lose mass over time. When a prominence erupts, it can send vast amounts of material into space, contributing to the star's gradual shedding of its outer layers. This process is particularly important for stars nearing the end of their lives, as it influences how they transition into their final stages, whether as red giants, white dwarfs, or even supernova. Moreover, prominences can tell us a lot about a star's magnetic environment. By observing these loops of plasma on distant stars, astronomers can map out their magnetic fields and better understand how they influence stellar winds and radiation. This, in turn, helps us piece together the complex puzzle of how stars evolve and interact with their surroundings. For example, in binary star systems, where two stars orbit each other, prominences can become even more dramatic. The gravitational pull and magnetic interactions between the stars can lead to massive, tangled loops of plasma that stretch across vast distances. These interactions not only shape the stars themselves, but also the space around them, influencing the formation of planets and other celestial bodies. By studying solar prominences on our sun and comparing them to those on other stars, scientists gain valuable insights into the universal processes that govern stellar life cycles. It's a reminder that the sun, while unique to us, is just one of countless stars in the cosmos, each with its own story written in loops of glowing plasma. As we continue our journey, the next section will take us even closer to home, exploring how solar prominences light up our skies in the form of auroras, connecting the sun's activity to the beauty we see on Earth. Now, let's turn our attention to one of the most breathtaking displays of nature, auroras. These shimmering curtains of light that dance across the polar skies are not just a beautiful spectacle, they are a direct result of the sun's activity, including solar prominences and solar storms. When a solar prominence erupts, it can sometimes trigger a solar storm, sending a surge of charged particles racing toward Earth. These particles, carried by the solar wind, travel across the vast expanse of space until they reach our planet. But Earth has its own defense system, a magnetic field that acts like a shield, deflecting most of these particles. However, near the poles, where the magnetic field is weakest, some of these particles manage to slip through. As these charged particles collide with gases in Earth's atmosphere, they create a stunning light show. Oxygen molecules produce green and red hues, while nitrogen gives off blues and purples. The result is the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere. These lights can stretch across the sky in ribbons, spirals, and waves, painting the night with colors that seem almost otherworldly. The intensity of auroras often depends on the strength of the solar storm. A powerful eruption from a solar prominence can lead to a geomagnetic storm, causing auroras to appear farther from the poles than usual. In rare cases, they can even be seen in regions closer to the equator, turning an ordinary night into a magical experience for those lucky enough to witness it. But auroras are more than just a visual treat. They are a reminder of the intricate connection between the sun and Earth. Every shimmering light in the sky is a testament to the sun's influence, a cosmic dance choreographed by solar prominences and magnetic fields. As we marvel at these lights, we're also reminded of the delicate balance that makes life on Earth possible. The same solar activity that creates auroras can also disrupt satellites, power grids, and communication systems. Yet, it's this very activity that fuels the beauty of our night skies, connecting us to the vast, dynamic universe beyond. Next, we'll delve into the potential dangers of solar prominences and how they can impact our modern world, exploring the fine line between awe-inspiring beauty and the challenges they pose. While the beauty of solar prominences and their connection to auroras is undeniable, there's another side to these cosmic phenomena that demands our attention: their potential to disrupt life on Earth. When a solar prominence erupts, it can unleash a torrent of energy and charged particles into space, creating what scientists call a solar storm. These storms, while mesmerizing from a distance, can have serious consequences for our modern, technology-dependent world. One of the most immediate effects of a powerful solar storm is its impact on communication systems. The surge of charged particles can interfere with radio signals, disrupting everything from air traffic control to emergency broadcasts. Satellites, which play a crucial role in global communication, navigation, and weather forecasting, are particularly vulnerable. A strong solar storm can damage their electronics, leading to temporary outages or even permanent loss of functionality. But the challenges don't stop there. Solar storms can also induce powerful electric currents in Earth's atmosphere, which can flow into power grids. These geomagnetically induced currents, or GIC, can overload transformers and other critical infrastructure, potentially causing widespread blackouts. In one notable example, a solar storm in 1989 left millions in Quebec, Canada, without power for several hours, highlighting just how vulnerable our energy systems can be. The risks extend beyond Earth's surface. Astronauts aboard the International Space Station or future missions to the Moon and Mars face increased exposure to harmful radiation during solar storms. Without adequate shielding, this radiation could pose serious health risks, from acute radiation sickness to long-term effects like an increased risk of cancer. Despite these dangers, scientists and engineers are working tirelessly to mitigate the risks. Advanced warning systems, such as those provided by the Solar Dynamics Observatory, allow us to monitor solar activity and predict potential storms. Power grid operators are also implementing measures to reduce the impact of GICs, such as installing protective devices and designing more resilient infrastructure. As we continue to explore and understand solar prominences, we're reminded of the delicate balance between the sun's awe-inspiring power and its potential to disrupt our lives. While these phenomena remind us of our place in the vast universe, they also underscore the importance of preparedness and innovation in the face of cosmic challenges. Next, we'll explore how solar prominences have been portrayed in science fiction, blending the lines between scientific fact and imaginative storytelling. Now, let's step into the realm of imagination, where science meets storytelling. Solar prominences, with their dramatic loops of plasma and explosive energy, have long captured the attention of science fiction creators. These fiery arcs of the sun have inspired countless tales, blending the awe of real science with the limitless possibilities of fiction. One of the most iconic portrayals of solar activity can be found in the classic science fiction film Sunshine, directed by Danny Boyle. In this gripping story, a crew of astronauts embarks on a mission to reignite the dying sun, facing the immense power of solar flares and prominences along the way. The film's stunning visuals bring the sun's raw energy to life, showcasing the beauty and danger of these phenomena in a way that feels both scientifically grounded and deeply imaginative. Books, too, have explored the dramatic potential of solar prominences. In Arthur C. Clarke's novel, The Songs of Distant Earth, the sun's instability plays a central role in humanity's struggle for survival. Clarke's vivid descriptions of solar eruptions and their impact on Earth paint a picture of a universe where the sun is both a life giver and a potential destroyer. Even in the realm of television, solar prominences have made their mark. The popular series, Doctor Who, has featured episodes where the Doctor and companions confront the sun's fury, using their wits and technology to navigate the dangers of solar storms. These stories often blend humor, adventure, and a touch of scientific curiosity, making the sun's mysteries accessible and entertaining for audiences of all ages. What makes these portrayals so compelling is their ability to take real scientific concepts and stretch them into the realm of the extraordinary. While the science behind solar prominences is fascinating on its own, fiction allows us to explore the what-ifs that lie beyond our current understanding. What if a solar storm threatened to wipe out all life on Earth? What if we could harness the sun's energy to power interstellar travel? These questions spark our imagination and remind us of the endless possibilities that lie within the cosmos. As we reflect on these stories, we're reminded of the dual nature of solar prominences, both as a source of scientific wonder and as a canvas for creative expression. They inspire us to dream, to question, and to explore the boundaries of what we know. Next, we'll look ahead to the future of solar prominence research, where cutting-edge technology and bold missions promise to unlock even more secrets of the sun. As we turn our gaze toward the horizon of discovery, the future of solar prominence research shines brightly with promise. Scientists and engineers around the world are working tirelessly to develop new tools and technologies that will allow us to peer even deeper into the sun's mysteries. One of the most exciting advancements on the horizon is the next generation of solar observatories, equipped with cutting-edge instruments designed to capture the sun's activity in unprecedented detail. These missions aim to unravel the complex interplay of magnetic fields, plasma, and energy that give rise to solar prominences, bringing us closer to understanding their true nature. Among the most anticipated missions is the European Space Agency's Solar Orbiter, which is already providing stunning images and data from its close encounters with the sun. By venturing closer to our star than ever before, this mission offers a unique perspective on solar prominences, capturing their formation and behavior in ways that ground-based telescopes simply cannot. Similarly, NASA Parker Solar Probe continues its daring journey, diving into the sun's corona to study the environment where prominences originate. These missions are not just about capturing breathtaking images, they're about gathering the data needed to answer some of the most pressing questions in solar physics. But the future of solar prominence research isn't limited to space missions. Advances in ground-based technology are also playing a crucial role. New telescopes equipped with adaptive optics and high-resolution imaging capabilities are allowing scientists to observe prominences with incredible clarity. These tools, combined with powerful computer simulations, are helping researchers model the intricate processes that drive these phenomena. By blending observation with theory, scientists hope to unlock the secrets of why some prominences remain stable for weeks, while others erupt violently into space. Yet, for all the progress being made, many questions remain unanswered. What triggers the sudden eruption of a prominence? How do magnetic fields within the sun interact to create these stunning loops of plasma? And perhaps most intriguingly, what can solar prominences tell us about the behavior of other stars in the universe? These are the puzzles that drive solar physicists forward, fueling their curiosity and determination to uncover the sun's deepest secrets. As we look to the future, one thing is certain: the study of solar prominences is far from over. With each new mission, each technological breakthrough, and each discovery, we move closer to understanding not just our own star, but the fundamental processes that shape the cosmos. The sun, with its fiery loops and explosive energy, continues to inspire and challenge us, reminding us that the universe is full of wonders waiting to be explored. Next, we'll delve into the connection between solar prominences and climate change, addressing common misconceptions and clarifying the role of solar activity in Earth's climate system. Now, let's turn our attention to a topic that often sparks confusion: the relationship between solar prominences, solar activity, and climate change. It's a common misconception that the sun's dramatic displays, like solar prominences and flares, play a significant role in Earth's changing climate. While the sun is undeniably the primary source of energy for our planet, the idea that its activity drives modern climate change is a misunderstanding that needs to be clarified. Solar variability, which includes changes in the sun's magnetic activity, sunspots, and phenomena like solar prominences, does influence Earth's climate to some extent. Over long timescales, such as centuries or millennia, small variations in the sun's energy output can contribute to shifts in global temperatures. For example, periods of low solar activity, like the Maunder minimum in the 17th century, coincided with cooler global temperatures during what's known as the Little Ice Age. However, these natural fluctuations are relatively minor compared to the rapid and significant changes we're witnessing today. The key difference lies in the scale and cause of these changes. Human activities, particularly the burning of fossil fuels and deforestation, have dramatically increased the concentration of greenhouse gases in Earth's atmosphere. These gases trap heat, leading to a steady rise in global temperatures, a trend that far outweighs the impact of solar variability. In fact, over the past century, while solar activity has remained relatively stable, global temperatures have risen at an unprecedented rate. This clear divergence highlights the dominant role of human-induced factors in driving modern climate change. It's also worth noting that solar prominences and other solar phenomena, while awe-inspiring, don't directly influence Earth's climate in the way some might assume. These events are more about the sun's magnetic activity and plasma dynamics, rather than its overall energy output. Even during periods of heightened solar activity, the changes in the sun's total energy output are minimal, typically less than 0.1%. This small variation is simply not enough to account for the significant warming we're experiencing today. So, while the sun's behavior is fascinating and plays a role in shaping Earth's environment over long periods, it's not the driving force behind the current climate crisis. Understanding this distinction is crucial for addressing the real causes of climate change and taking meaningful action to mitigate its effects. By focusing on reducing greenhouse gas emissions and transitioning to sustainable energy sources, we can tackle the challenges posed by a warming planet. Next, we'll explore how solar prominences and solar activity impact human exploration of space, particularly the risks they pose to astronauts and spacecraft venturing beyond Earth's protective atmosphere. As we venture further into the cosmos, the mysteries of solar prominences take on a new level of importance, especially when it comes to human exploration of space. These stunning loops of plasma, while beautiful to observe, pose significant challenges for astronauts and spacecraft traveling beyond the safety of Earth's atmosphere. Understanding solar prominences isn't just about appreciating their beauty. It's about ensuring the safety and success of missions to the Moon, Mars, and beyond. One of the greatest risks posed by solar prominences is their connection to solar radiation. When a prominence erupts, it can release bursts of high-energy particles into space, creating what's known as a solar storm. These storms can be particularly dangerous for astronauts who are exposed to higher levels of radiation outside Earth's protective magnetic field. Even inside a spacecraft, the shielding may not be enough to fully protect them from the intense radiation during a major solar event. This makes monitoring solar activity, including prominences, a critical part of mission planning and astronaut safety. but the risks don't stop at radiation. Solar prominences and the associated solar storms can also interfere with spacecraft systems. High-energy particles can damage sensitive electronics, disrupt communication signals, and even affect navigation systems. For missions to the Moon or Mars, where communication with Earth is already delayed, a sudden solar storm could create serious complications. That's why space agencies like NASA and others closely monitor the sun's activity, using advanced tools to predict and prepare for these events. Interestingly, solar prominences also offer a unique opportunity for scientific discovery. By studying these phenomena, scientists can better understand the sun's magnetic fields and plasma dynamics, which in turn helps improve our ability to forecast space weather. This knowledge is invaluable for designing safer spacecraft and developing strategies to protect astronauts during long-duration missions. For example, future habitats on the Moon or Mars might include specially designed shelters to shield inhabitants from solar radiation during intense solar events. As we look ahead to the next era of space exploration, the role of solar prominences becomes even more significant. Missions to Mars, for instance, will require astronauts to spend months or even years in space, far from Earth's protective shield. Understanding and mitigating the risks posed by solar activity will be essential for ensuring their safety and the success of these ambitious endeavors. So, while solar prominences captivate us with their beauty, they also remind us of the challenges we must overcome as we reach for the stars. By studying these phenomena, we not only deepen our understanding of the sun, but also pave the way for humanity's future among the stars. Next, we'll explore how artists and scientists collaborate to bring the beauty of solar prominences to life, creating visual representations that inspire and educate. Now, let's step into the fascinating world where art and science converge to bring the beauty of solar prominences to life. Visualizing these incredible loops of plasma is no small feat, and it takes a unique collaboration between artists and scientists to capture their essence in ways that inspire and educate. Scientists provide the raw data, images, measurements, and observations gathered from telescopes and space probes, but translating this data into something visually stunning and easy to understand is where artists come in. Using their creativity and technical skills, they transform complex scientific information into breathtaking visuals that make the mysteries of the sun accessible to everyone. One of the biggest challenges in visualizing solar prominences is capturing their dynamic nature. These loops of plasma are constantly shifting, twisting, and erupting, making them difficult to represent in a single image or animation. Artists often rely on time-lapse sequences or composite images to show how prominences evolve over time. This not only highlights their beauty, but also helps scientists study their behavior in greater detail. Another challenge is conveying the sheer scale of these phenomena. Solar prominences can stretch hundreds of thousands of kilometers into space, dwarfing even the largest planets in our solar system. To help viewers grasp this immense scale, artists often use creative techniques, such as overlaying Earth or other familiar objects for comparison. This gives us a sense of just how massive and awe-inspiring these structures truly are. Color also plays a crucial role in these visualizations. Since solar prominences are not visible to the naked eye, artists use color to represent different temperatures, densities, or magnetic fields. For example, cooler regions might be shown in deep reds, while hotter areas could appear in vibrant blues or whites. These color choices are not just artistic. They are based on scientific data, helping viewers understand the complex physics at play. The collaboration between artists and scientists doesn't just result in stunning visuals, it also sparks curiosity and wonder. By making the sun's activity more relatable, these visualizations inspire people to learn more about our star and its impact on our solar system. They also serve as powerful tools for education, helping students and the public alike grasp concepts that might otherwise seem abstract or intimidating. As we continue to explore the sun and its mysteries, the role of art in science will only grow more important. Together, artists and scientists are not just documenting the universe, they are helping us see it in new and extraordinary ways. Next, we'll delve into how solar prominences might hold clues in the search for life beyond our solar system, connecting these fiery loops to the broader quest for understanding the cosmos. As we turn our gaze beyond our own solar system, the study of solar prominences takes on a new dimension, one that could hold the key to unlocking the mysteries of life elsewhere in the universe. These fiery loops of plasma, so mesmerizing on our sun, are not unique to our star. In fact, they are a common feature of many stars, and understanding their behavior could provide critical insights into the habitability of distant worlds. Stellar activity, including the presence of solar prominences, plays a significant role in shaping the environments of planets orbiting other stars. Just as the sun's activity affects Earth, the behavior of a star can determine whether a planet is a potential haven for life or a hostile, uninhabitable wasteland. For instance, stars with frequent and intense prominences may bombard their planets with high levels of radiation and charged particles, which could strip away atmospheres or make surface conditions too extreme for life as we know it. On the other hand, stars with more stable and moderate activity might offer the right conditions for life to thrive. By studying solar prominences on our sun, scientists can develop models to predict how similar phenomena might behave on other stars. This knowledge helps astronomers identify which stars are most likely to host habitable planets, narrowing the search for extraterrestrial life. One fascinating area of research is the connection between stellar activity and the concept of the habitable zone, the region around a star where temperatures are just right for liquid water to exist. While the habitable zone is often thought of as a fixed distance, the reality is more complex. A star's activity, including its prominences, can influence the boundaries of this zone. For example, a star with frequent eruptions might push the habitable zone farther out, as closer planets would be exposed to too much radiation. Moreover, solar prominences and other stellar phenomena can affect a planet's atmosphere and magnetic field, both of which are crucial for protecting life from harmful cosmic rays. By studying how these processes work on our sun, scientists can better understand how they might operate on other stars, providing clues about which planets might have the right conditions to support life. The search for extraterrestrial life is not just about finding planets in the right place, it's also about understanding the stars they orbit. Solar prominences, with their dynamic and complex nature, offer a window into the behavior of stars across the galaxy. As we continue to explore these phenomena, we move closer to answering one of humanity's most profound questions. Are we alone in the universe? Next, we'll reflect on how solar prominences fit into the bigger picture of the cosmos, connecting these fiery loops to the broader understanding of the universe and our place within it. As we step back to consider the grand tapestry of the cosmos, solar prominences reveal themselves as more than just stunning displays of plasma. They are threads woven into the fabric of the universe itself. These fiery loops, so vivid and dynamic on our sun, are part of a much larger story, one that connects the behavior of stars to the evolution of galaxies and the very structure of space and time. In the realm of astrophysics, solar prominences serve as natural laboratories, offering scientists a chance to study the fundamental forces that govern the universe. The interplay of gravity, magnetic fields, and plasma dynamics seen in these phenomena mirrors processes that occur on much larger scales, from the birth of stars to the collision of galaxies. By understanding how solar prominences form and evolve, researchers gain insights into the mechanisms that drive cosmic events far beyond our solar system. Cosmology, the study of the universe as a whole, also benefits from the study of solar prominences. These structures remind us that the Sun is just one star among billions in the Milky Way, and each star has its own unique story of activity and evolution. The behavior of solar prominences on our Sun provides a baseline for understanding stellar activity across the galaxy, helping astronomers piece together the life cycles of stars and their impact on the cosmos. Moreover, solar prominences highlight the delicate balance of forces that shape the universe. The magnetic fields that create these loops are the same forces that power pulsars, shape nebulae, and drive the jets of energy from black holes. In this way, the study of solar prominences connects us to the broader mysteries of the cosmos, from the smallest particles to the largest structures in existence. As we reflect on the significance of solar prominences, we are reminded of our place in the universe. These fiery loops are not just a spectacle to behold, they are a reminder of the interconnectedness of all things. From the sun's surface to the farthest reaches of space, the forces at work in solar prominences are the same forces that shape the destiny of galaxies and the evolution of the universe itself. Looking ahead, the study of solar prominences continues to inspire new questions and discoveries. What can these phenomena teach us about the early universe? How do they influence the formation of planets and the potential for life? As we explore these questions, we deepen our understanding of the cosmos and our role within it, guided by the light of our own star and the mysteries it holds. Next, we'll celebrate the awe-inspiring beauty of solar prominences and how they continue to captivate our imagination, reminding us of the endless wonders waiting to be discovered in the universe. As we turn our gaze to the final chapter of this cosmic journey, it's impossible not to feel a sense of wonder at the sheer beauty and mystery of solar prominences. These loops of plasma, dancing on the sun's surface, are more than just scientific phenomena. They are a source of inspiration, sparking curiosity and creativity in all who witness them. Solar prominences remind us that the universe is a place of endless discovery. Their fiery arcs, stretching thousands of kilometers into space, are a testament to the power and elegance of nature. They invite us to ask questions, to explore, and to dream. What drives these magnificent structures? What secrets do they hold about the sun and the stars beyond? Each observation, each image captured, fuels our desire to understand the cosmos and our place within it. For artists and storytellers, solar prominences are a wellspring of inspiration. Their dynamic forms and vibrant colors have been depicted in paintings, photographs, and even science fiction, capturing the imagination of audiences around the world. They remind us that science and art are not separate endeavors, but two sides of the same coin, both seeking to reveal the beauty and complexity of the universe. For scientists and researchers, solar prominences are a call to action. They challenge us to push the boundaries of our knowledge, to develop new tools and technologies, and to explore the unknown. Every breakthrough in understanding these phenomena brings us closer to unraveling the mysteries of the sun and the stars, and with each discovery, we gain a deeper appreciation for the forces that shape our universe. But perhaps most importantly, solar prominences inspire a sense of connection. They remind us that we are part of something much larger than ourselves, a universe filled with wonders waiting to be explored. Whether you're an astronomer peering through a telescope, an artist capturing their beauty on canvas, or simply someone gazing at the night sky, solar prominences invite you to marvel at the cosmos and to find your own place within its vast expanse. As we conclude this exploration, let us carry this sense of wonder with us. Let the mystery of solar prominences inspire you to look up, to question, and to dream. The universe is full of stories waiting to be told, and each of us has a role to play in uncovering them. So, the next time you see the sun's fiery loops, remember, they are not just a spectacle of nature, but a reminder of the endless possibilities that lie beyond our world. Thank you for joining us on this journey through the mysteries of solar prominences. If you enjoyed this exploration, don't forget to like, subscribe, and hit the notification bell for more sleep stories and space-themed content. Until next time, keep looking up and let the wonders of the universe inspire your dreams. As we bring this journey to a close, let's take a moment to reflect on the incredible story of solar prominences. These loops of plasma, born from the sun's fiery surface, are not just scientific marvels, but also windows into the workings of our star. We've explored how they form, driven by the sun's magnetic fields and the interplay of gravity and heat, and how they captivate both scientists and artists alike. From their role in space, whether to their breathtaking beauty, solar prominences remind us of the sun's dynamic nature and its profound influence on our solar system. But beyond the science, solar prominences hold a deeper significance. They are a reminder of the mysteries that still surround us, even in our own cosmic backyard. The sun, a star so familiar yet so enigmatic, continues to challenge our understanding and inspire our curiosity. Each loop of plasma, each eruption, tells a story of forces far greater than ourselves, inviting us to look closer and ask bigger questions. As we step away from this exploration, let's carry forward the sense of wonder that solar prominences evoke. Whether you're gazing at the sun through a telescope, marveling at images from space observatories, or simply pondering the vastness of the universe, remember that there is always more to discover. The mysteries of the sun and the stars are not just for scientists, they are for all of us, a shared journey of exploration and understanding. So, as the sun sets on this story, let it rise on your own curiosity. Keep looking up, keep asking questions, and keep dreaming of the wonders that await. The universe is vast, and its stories are endless. Who knows what mysteries you might uncover next? Thank you for joining us on this cosmic adventure. If you enjoyed this journey through the mysteries of solar prominences, don't forget to like, subscribe, and hit the notification bell for more sleep stories and space-themed content. Until next time, keep your eyes on the stars and let the wonders of the universe light your way. Before we part ways, let's take this moment to connect. If this journey through the mysteries of solar prominences sparked your curiosity, I'd love to hear your thoughts. What fascinated you the most? Was it the science behind these loops of plasma, their breathtaking beauty, or the way they remind us of the sun's dynamic power? Share your reflections in the comments below. Your insights might inspire others to look at the night sky with fresh wonder. And if you're eager for more cosmic adventures, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, from the secrets of distant galaxies to the hidden stories of our own solar system. Each video is a new opportunity to dive deeper into the mysteries of the universe, and I'd love for you to join me on this journey. Finally, as you go about your day, take a moment to look up at the stars. Whether it's a clear night or a cloudy one, remember that the cosmos is always there, waiting to be discovered. Let the wonders of the universe ignite your imagination and remind you of the infinite possibilities that lie beyond our world. Thank you for being part of this cosmic exploration. Until next time, keep dreaming, keep wondering, and keep your eyes on the stars. The universe has so much more to share with us, and I can't wait to uncover it together.